Okay, probably the most important lesson of the whole unit, solving equations. We're going to work on this today, and I'd like you to pay attention closely to the method because I really want you to learn this procedure, even though most of the time I'm all about the conceptual understanding, etc. This is a procedure that will come in very, very handy for you and make things much easier to accomplish. So whenever you're solving equations, your goal is to solve for the variable. You want to get it alone. And a cardinal rule is whatever you do to one side of the equation, you must do to the other to keep it balanced. Remember when we were working with algebra tiles, like if there was something on a balance, and then if it said like these equal each other, but if you took one off of this side, then the scale would start to tip. So you have to do it to the same thing to both sides. All right, if necessary, I want you to simplify each side of the equation first, and then you undo using reverse order of operations because you're working backwards. And then always check your solution. Let's do several examples together. And I want you to kind of play Simon Says with me. Whatever I do, you do exactly like this on your paper. All right, so first thing, 2x minus 1 equals -9. I'm trying to get x alone. I'm going to draw a line down my equal sign so that I can see, here's my two sides. I want to do the same thing to both sides. All right, to this x is being multiplied by 2 and subtracted 1. Subtracting is last in the order of operations, so I'm going to undo it first in this situation. So to get rid of a -1, I add 1. I'm going to add 1 to both sides. Then I like you to see what's left. After you had 2x minus 1 plus 1, the minus 1 and plus 1, I'm zeroing out. You're just left with the 2x on the left. And on the right, you have -9 plus 1. We have -8. So now you have 2x equals -8. You're not quite done because x isn't alone. X is being multiplied by 2. So to undo multiplication, you use the inverse operation division. I'm going to divide both sides by 2. 2x divided by 2 is just x. -8 divided by 2 is -4. So I believe my solution is x equals -4. And then I'm just going to check it briefly. So what I'm going to do is I take my -4 that I got and I plug it into the equation for x. So I replace x with -4. I write everything else down as it is and I just see if this makes it true. So 2 times -4 is -8. -8 minus 1 is -9. It says my answer should be -9, and it is, so this works out. All right, let's try another one. So x divided by -3 plus 5 equals 1. Again, Simon Says do exactly what I do. All right, I'm drawing my line. All right, we have division and addition. Addition is last in order of operations. I'm going to undo that first. Subtract 5 from both sides. I'm left with x divided by -3 equals -4. Okay, to undo division, I multiply. So I'm dividing by -3, so I'm going to multiply both sides by -3. All right, x divided by -3, then times -3, that's just x. -4 times -3 is 12. Some people have a hard time seeing this x on the left. Like when I multiply by -3, I'm multiplying by -3 over 1. So if I multiply -3 over 1 by x over -3 and I go straight across, I get -3x over -3. And since here, -3 divided by -3 is 1, I just have 1x. So you can see where these end up canceling out, like if you think of cross-canceling when you're multiplying fractions. X equals 12, and again, I'm going to check it. So I plug in 12 for my x. 12 divided by -3 plus 5, does that equal 1? Well, 12 divided by -3 is -4. -4 plus 5 is 1. So yes, 1 equals 1. I got it right. All right. Try this on your own if you can, but it has an extra twist, so you might need to follow along with me. All right, so I've got variables on both sides this time. And I really want to get a variable alone on one side by itself, so I need to get rid of the variables from one side. So I would probably take away 5m from both sides first, just because I prefer working with the positive variable, but you could take away 7m from both sides as well. When you take away 5m and -5m, that's like terms, they zero out, you're left with 1 equals 7m minus 5m is 2m, and I still have this plus 11. Now this looks a lot simpler, like a normal equation you've done. So I'm going to subtract 11 from both sides, and I get negative 10 equals 2m. I'm trying to get m all by itself. It's being multiplied by 2, so I'll undo by dividing by 2. And then I have negative 5 equals m. Okay, and last step, I'm going to check this. And I'm going to plug in negative 5 wherever I see an m. And this time there's more than one m. So I have 5 times negative 5 plus 1. I want to see if that's the same thing as 7 times negative 5 plus 11. So then I will simplify both sides. 5 times negative 5 is negative 25. Negative 25 plus 1 is negative 24. And then on the right, 7 times negative 5 is negative 35. Negative 35 plus 11 is negative 24. Negative 24 does equal negative 24, so I must have the right solution. All right, last one. So this time I have to do some simplification first because I have some distributive property here on the left side. Well, that's one way to do it. There's another way as well, or maybe more than one way, but I'll show the distributive property way. So I'm going to multiply 3 by each thing in the parentheses here. So 3 times negative 2n is negative 6n. 3 times 1 is 3. And I have negative 6n plus 3 equals 15. Now it looks like a simple two-step equation. So I'm just going to do the same thing to both sides now that I've got it simplified. Negative 6n equals 12. Divide both sides by negative 6. And I have n equals negative 2. And if I check this, then I'm going to see again, I'm going to put in negative 2 in for n. And then I have 3 times negative 2 times negative 2 plus 1, all in parentheses, equals 15. And I'll solve this using order of operations. So in parentheses first, and multiplication comes before addition. So negative 2 times negative 2 is 4. And then I have 4 plus 1 in parentheses times 3. 4 plus 1 is 5. And 3 times 5 is 15, which is the answer I'm supposed to get. So I must have this right.